Hey everyone, welcome to the second lesson in Unit 1. In this lesson, we will talk about constants, variables, and data type. What we will talk about, we'll start with the constants, and then we'll talk about variables. Then we'll talk about when to use constant, when to use variables, and then the naming, how to name variables, some of the rules about naming variables. We discuss comments, and then we discuss the most common types of variables. Then we'll talk about data types, and we will cover type inference at the end, type safety, and then at the end of that, we will do the lab. All right. So let's get started with the keynote. So what is a constant and what is a variable? Basically, when we talk about constants and variable, it is a way to associate a name in the computer with a value. We define a constant or a variable. When we define a constant or a variable, we allocate storage in memory to store the values on the for those variables. Then you associate the constant name with that assigned value. All right. This is in a simple way. It's just a place inside the memory where we can store value. That memory, we give it a name, and that name is the variable or the constant. Here is an example of a constant. The constant means that you cannot change the value later on. So we define constant by using the keyword let here. And in this case, we say let name equal John. So the name is my variable name. The keyword let is my keyword that identify this variable as a constant. All right. And then we're putting a value. This value called is John, will be stored in this variable. This is a type of variable that is a string. This one is a double. In this case, we have another variable. Again, we use the let keyword, pi equal 3.14. Now, when you define these as constant, you cannot change them later on. So in this case, when I say let name equal John, I cannot go later on in my program and say name, I'm going to change the name, because this is you will get an error, compiler error. It says name is a constant, and you cannot reassign its value. All right. So that's the basic way of creating constants. On the other hand, variables are just that, like the name suggests, you can change them. They change their values. So in this case, we use the keyword var, again, the variable name, and then the value that we want to assign to it. Now, if you define something as a variable, it's okay to change the value later on. So in this case, we change the variable, we define a variable called age, and then we were able to change it, and I did not get the compiler error when I run my program. All right, so this is another example. This is default score is equal to 100, and then variable player 1 score, player 2 score, and then these are default scores. So it's okay to assign a variable a constant value, and you can still change it. It's no problem. So when you do this, you're basically taking the 100 and assigning it to that player 1 score, and then you're taking the 100 here and assigning it to player 2 score. So if you define a constant, you can assign that constant to different variable with no issue. All right. Here you can print it. When you print it, this is what you get. Now these are variables. You can change their values and no issues. All right. So you can define a constant, but you can assign it to a variable, and then that variable can be changed. Here is an example. Now we're going to look at this example, and we're going to determine which is a constant and which is a variable. Now we're going to make some assumption here. The assumption here is that we're dealing only with one trip. That means the starting point and the ending point are not going to change for us. All right, I'm giving you a hint here. All right, so what is a variable here? Is the starting point a variable? It is not. So the starting point, is it a constant or a variable? Again, I made an assumption that these will not change. So I'm assuming the answer is what? Is a constant, right? So the starting point is a constant. The destination is also a constant. How about the current location? Does the current location, as you travel on this trip, do you think it is going to be a constant or a variable? Obviously, this changes as you travel alongside the roads or on the roads. So that is a variable. How about the distance traveled? Again, this will change as your position changes on the map. So that is also a variable. What about the remaining distance? If the distance traveled is variable, this is going to be a variable as well, because they are related to each other. All right, so this is so when you're defining your application, this is kind of an idea. How would you derive which is a constant and which is a variable? Things that are going to change in my applications will be variables. Things that are more likely not going to change will stay as constants. All right, so how about when we rename variables? There are some rules, really simple rules. You cannot use any mathematical symbols such as plus, minus, divide, the remainder or module. You cannot use any of that in the variable name. No spaces in the variable names. You can't have, for example, first space name. No, you can't do that. You cannot have, and no spaces obviously mean white spaces. You cannot have a tab either, right? You cannot begin with a number. But everything else is okay. So you can have Unicode, including emoji symbols. It makes the language easier for non-English speakers or non-English text. So in this case, a pi is a Unicode character, or so it's okay. This is emoji, or I don't know what language it is. This could be Korean. So that's okay. This is emoji, so that's fine. Here's another language. Here's another language. So you could have any Unicode characters to define your variables. All right. So these are the rules of naming variables. Now, there are some suggestions and standards best practices that we follow. Your names should be, your variable names should be, or constant name should be descriptive. So I don't have to trying to discover what this variable means in the program, especially if you have like hundreds and hundreds of lines of codes and you have all these different variable names. So you need to be careful how you name your variable names and don't use things like this. And instead we use first name. So that is no, this is okay. Now you need to use, or the very common one that people use is camel casing, meaning what? Means which one is easier to read? Do you think this is first name or this one is easier to read? If you look at this, you think that it is one word and you're trying to figure out how do you say it. But if you look at this, you can see that first, capital and name. So you can distinguish the words in the variable name. So this is one way to do it, use camel casing. There's other ways. Some people put underscore between the words, so that's okay as well. But this is the standards we follow here. All right. That's related. That's regarding the naming naming of the variables. So what about comments? Comments are nodes in your program that helps developer later on understand what you're trying to do. So for example, you can have two ways to write comments in your code. One way you put double slash. This is very similar to other languages like Java or C, double slash, and then you will put the comment that you want to specify. So this one get ignored by the compiler. It will not, when you run your program, it says, oh, this is a comment. I'm not going to skip it. I'm going to skip it and then go to the next one. And the same thing, this is another way to put comments. If you have multiple lines, slash star asterisk, and then you write your comments, and at the end you will put asterisk and then slash to close your comment. All right, before we get to that, what we're going to do is that let's practice some of the things that we've done here and test it. All right, so let's open the storyboard that we've done before, and let's define some variables, define some constant, and test the things that we've learned so far. All right, so you can do that with me. I'm gonna minimize this for a minute. All right, so here is our desktop, and here is Xcode. And let's open Xcode again. And let me show you what happens when you open Xcode. Because I have it open in other places, so I'm going to close it. Let me close it and open it again for you, so see what happens. Okay. So when you open Xcode, what you will see, you will get that menu again, but you will see that the playground that we worked on last time is here in the most recent project. So I can double click on this, and then it will open Xcode for me, or the playground that we've been working on last time. Okay, so that's what we did last time. We defined some variable names, and we printed out some of the text here and some of the variable names. All right, so let's test this theory. So I got first name. So first I'm going to define, this is a comment. So let's say define some constants. All right. And try to change them. Okay, so that's the first part. So we're going to say let pi equal 3.147. All right, so what happens here? Now this pi is a constant. Now, if I do print pi, what will happen? It will print the value that is stored in that variable. So remember, how do we run it? We just simply click on this, and then if you want to show the debug area, because we're running it for the first time, so it might take a little bit here when you say it's ground. So okay, so I printed out the messages that we had before, and then this is the pi, right? Now, if we try to change that pi, so if I say, if I try to say pi equal, instead of I wanted to make my own pi 3.15, I want to round it up to 3.15. Now we get an error, and that error is saying that you cannot change pi because it's a constant. All right, so that's the first error. All right, so now what about if we want to define some variables? You already have one already defined above. All right, how do we define a variables? We define a variable by just using the keyword variables. So I'm gonna do radius, and I'm gonna give it a value. This radius is going to be 2.5. All right, and I am going to define another variable here, which is called circle area. And then I'm going to say here 2 pi r, right? Oh, parameter, the area is 2 pi r square, which is 2 times pi I'm not sure about I'm not sure about the area, but it's okay. I think it's pi r square or 2 pi r square, or pi, just pi r square, I think. So pi times, you can check me on that, and then radius, and then I'm going to multiply it by itself. So radius, so for now, and that is the circle area. Now, if I try to print it, so we say print the circle area. If I want to print the radius, I can say like this: radius, circle radius equal, and then I can say that, and I put radius here. Okay, and I can say print the area is and I got a radius misspelled here. All right, so the circle area is going to be circle area. Of course, bear with me. All right, and then we're gonna do circle area. Here we're gonna print circle area. All right, and that's it. So let's test it and see what happens. So if I run this, this is the circle radius, this is the circle area. And now let's try something different here. What we wanted to do, can I change the radius? Yes, you can. You can say radius, the new, we want to calculate the area for another circle here. So we're going to say circle area equal, sorry, we're going to say radius. Now we got a bigger circle, it's 5. And now I can do this. Just copy and paste these again. This is not the right way, but I just want to show you that this is doable, right? Now we can't define those because they are already defined. You don't need to define them again, right? So it's already defined because we defined it above here. No need to define it again, all right? So now we can run it, and then I got my circle area. Okay, so that is how we define variables, how we define constants, and notice we used a constant in a variable, and that's still okay. When we did the calculation here, again, that was okay as well. Now, the naming conventions for the for this, again, if we said there are some rules naming variables, so I cannot say var last name space equal Farhad, for example, right? That is not allowed because you got she should have gotten a compiler error here. Yeah, you get a compiler error saying that this is not allowed, right? So what you need to do, you need to get, you can do it this way if you want, or the better way is that we use camel casing. So that's fine. And then you cannot use numbers in your variable name or constant name. So first say, for example, you can say first, you can't say first player score equals some variable, some value. right? Why you cannot do that? Because this is not allowed as well. You cannot start with a number, all right? So instead of that, you will use first player score, right? Or you cannot use mathematical symbols in the variable name. So this one also with, if you do this, it will say, okay, this is one variable, this is one variable, and you're trying to do some operation. So you cannot use this in that, you confuse the compiler. So that is not allowed either, all right? So that's a no-no. Okay, so those are the rules. Now, I don't have other languages. I do have Arabic here. Let me see if I can write something in Arabic. Let's see if I can write this in equal. Let's see if that works. I haven't tried it. And then, yeah, let's change that to back to English. Ali. Let's see if that works. It did not like that, because the problem with Arabic, it is from left to right. So that does not work very well. All right. But other languages like that are Unicode, then that's okay, apparently. So let's see if we can delete that. Yeah. All right. So that is it. Let's stop here and go back to the PowerPoint and continue with the type. All right. So I'm going to pause for a minute. All right. So we're going to go to the keynote. Here's my keynote. Oh, is it not showing? It is this one here, right? So let's make it bigger. We did the comments, we did the variable names, we did the constants, and we checked the some of the rules about naming conventions, the naming of the variables. This one is, we're gonna look into this in a lot more details later on. For now, I'm just gonna explain it to you, but there is a whole chapter that talks about this. So I'm just gonna highlight the features. So when we talk about types, basically a grouping of properties and functions. So these are called properties, attributes. Sometimes they have a different name, sometimes called attributes. They have functions as well, methods, sometimes they're called methods. So notice here you have a keyword called the structure. There's another keyword that we can use later on, which is called the class. And then the name of that data type, it's called person. And these are the grouping, the attributes that belong to that person. And these are the function that are that also associated with that person, or that person can do. All right. So it has behavior and it has attributes or properties. All right. The next example is more complex one. So we have a person. Now here's how you create how do you use this data type. You create this data type and you pass to it the attributes that you want to. So you have two different persons, and then each one will have its own different values. Again, I'm not going to cover these in details now. There's a whole chapter that talks about this. So what are the most common data types? The most common data types are integers. The symbol for it is int, double, the word for it is double, boolean, and a string. So what are these? Integers to represent whole numbers, if I want to store only whole numbers. Double allow you to store decimals, if you want to store decimal points. Then Boolean is mainly true or false. It's like a flag. Something is true or false, only those two values. And at the end, you have a string. All right. So those are my common variables that we use quite a bit. And in most cases, this is more than enough. All right. In most cases. There is something called type safety. That means you cannot assign a variable to another variable if the types are not compatible. What does that mean? So in this case, player name is Julian, player score is 1,000. This is inferred as string. Remember, we talked about type inference. This is inferred as a string. This is inferred as an integer because it has no decimal points in it. And then this is a Boolean. So you cannot say play score equal player name because there are two different types. All right. So this will give you an error at the compile time. Same thing with this. So you cannot, here in this case, this is a whole number, which is 30. This is another number, which is decimal, which is double. So this is integer, this is double. You cannot assign a decimal, a double to an integer because you would lose some positions. All right. So that is not allowed. All right. So when you're trying to assign variables, you need to make sure that they are compatible. They can actually be assigned to each other. All right. In most cases, you want to make sure that they are at least the same type. There are different ways we can do that, which is called casting. We'll talk about this in another chapter. Here's the type inference. We talked about this. This is a city name because we're assigning a string value to this variable name. This will become a string. And then how do we know it's a string value? You have these single double quotation around it. This one is the pi, and this one, the pi is 3.14597. Then this one also is double, right? Because this has decimal point in it. All right, there are type annotations that sometimes we need to specify what is the type of the variable name. In this case, those are pretty straightforward and we were okay with it. So whether we include string or not, it would infer that this is a string value. So city name, colon, and then the type that we want. So here I'm telling the compiler, this is a string, right? And I'm putting a value, string value in it. Same thing with pi. Pi is double, and I'm putting a value, double value in it. Even if this is, in this example, even if number is double and I'm assigning an integer value on it, that's okay. So because it says, okay, yes, this is a double, and I can assign whether you put a decimal on it in it or not, it can be assigned to this variable. All right. Now, the next thing that we're going to see is that there are cases where you must specify the data types. All right. Or for example, the variable types. For example, in this case, when you create a constant or a variable without assigning a value to it. So in this case, I'm defining a variable, but I have not assigned a value yet. In this case, I have to specify what is the type of that variable because the assignment comes later on. If I did the assignment at the same time, like first name equal Leon, then we wouldn't have to put that variable type again. All right, here. All right. The second case is that if you define a constant or a variable that can be interpreted in two different ways, two or more different ways, or inferred as two or more different data types. What does that mean? So if I did not put character here, character is another data type that we did not discuss. If I did not put a character here, it will consider this as a string. So if I wanted to define this as a string, as a character, then I define this as I define this variable name middle initial as a character, and I assign a character value to it. Characters and strings in Swift are kind of similar. The only difference here, character, you can store only one value, one letter. With a string, you can assign multiple letters to a particular variable. Same thing here, remaining distance. It's a float. but the value that I'm assigning to it is actually an integer. So if I did not put a float here, and then I just put remaining distance, it will consider this as an integer, and then again, you're stuck with it. And if you try to put a decimal point later on, it'll be a problem. So because I'm using integer here, value, I want the variable remaining distance to be a float, and then I specify it as a float. All right. The last scenario is if you define if you define a type that if you define a type, data type, and then you include properties in it. So here, these properties, let, make, model, year, all have to have data types in it, because you're not assigning any values at that time for that data type. You create them, you assign them as you create copies of these different cars. All right. So those are the three different ways, different scenarios that you have to specify the data type or the variable types, the variable and the constant types. So here's an example. You just put var x, you will get an error. You need to put need to specify what type it is, and then you can print it. You will get an error because they have not assigned any value to it yet. So before you can use it, you need to initialize it, and you need to put a value in it, right? The last thing we cover in here is that sometimes you store big numbers in a particular variable, and you get confused about the number of zeros. So Swift has introduced to you as numeric literal formatting. So you can separate these digits by putting an underscore. So for example, here, this is a 1 million, and then you will put, no, this is 1 billion, I guess. And then you will put underscore between the after each three zeros. All right. All right, so that is it. What you need to do, you need to open the lab and do the assignment in the lesson 2, and the playground, open the playground and follow the instructions in there. All right, so let's go back to the playground and test what we talked about in a little bit farther. Okay, so let's look at the type safety and make sure that you cannot assign incompatible variables to each other. All right, so let's say we define player name. So this is type safety. And then let's say player name equal Omar. And then let's say player score. Again, we need var, or let. Player name is not going to change, so we're going to make that let. And here we're going to make that var, because the score can change. And then it's going to be starting with 100. And variable game over equal false at the beginning. And this is a Boolean variable. And then if I try to do this, if I try to say player name, player score, and try to assign it the player name, you will get an error. Why? Because these are different data types. This is a string, and this is an integer, and you're trying to assign an integer to a string. So that's one scenario. Now, this we can do casting later on. I'll explain to you about casting, but this is actually is not applicable here. So I'm going to comment this guy here and leave it as an example. And what about the other thing? So if you cannot, we've talked about integers and doubles in general are bigger than integers, and they have decimal points. So you cannot assign integers you cannot assign double into an integer. All right. So if I say var whole number, and then if I say equal to 30, and then if I say here for var decimal number, and I'm going to give it some decimal value. And then if I try to say whole number, assign it the decimal number, you will get an error here. All right. So here again, you cannot assign double into an integer type. Again, this case, you can cast it, you can downcast it to an integer, which we will cover in a different lesson. All right, so I'm going to comment that out. All right, so let's see what else we're going to do here. All right. All right, so now what we're going to do is that I said that you can assign a type to a particular variable name. In this case, it was okay. But if you wanted to say that I want to make sure that the player name is a string, so what you can do, you can put colon, and then you specify string for that variable name. Same thing you could do with the same thing with the player score. So if you want this to be an integer, you can say this is an integer variable name. All right. Here you can specify this also as an int, and this is as a float or double, and that is okay. All right, so now here this is an integer variable name, this is a double variable name, this is a double variable, and then you can assign different values. Now you can assign, you can make this a double even though you're putting an initial value of 30, which has no decimal point in it, which is considered as an integer, by forcing it or by specifying it that this is a double. So if you did this part, then this will work. So that is not an issue anymore, right? Because the two variables are the same type. All right. So you can specify a type to a particular variable name by putting a colon after, and then the type name that you want to specify. All right, so the next part is that when do we need to specify a type annotation? So what you do is that you can say here, you need to, there are three different cases. We're going to cover only the two cases. The last case is already, will be explained in its own chapter. But let's look at the first two cases, which is the first one is that when you don't assign a value to it. So for example, if I say, let this is type annotation. If I say here, let family name, and then if I go put here, and I don't put a variable, I don't put a type to it or a value in it, then you will get an error. So you have to put you have to give it either a type or a value. So in this case, I can give it a type, which is a string. So the first case is that when you do not assign an initial value to it, you need to give it a type. And that is the first case. And here if I try to print it, you will get an error. If I try to print family name, you will get an error because you have not initialized it yet. So what you need to do before you use this variable name, you need to initialize them. And you can say family name equal, and then that is okay in this case. All right, so this would work. So the first scenario, if you define a variable and you have not initialized it yet, you need to give it a type. All right. The second scenario is that if you if you define a variable that can be interpreted in two different ways. Okay, so this is scenario one. First case. All right, and this is the second case, where you specify that you define a variable. That variable is ambiguous. The compiler is confused. What do you want? Is it an integer, or is it a double? Is it a string, or is it a character? So what do you do? For example, if you say let middle initial, and then I say it's character. It's a character is another data type, as explained in the PowerPoint. And then here you can put the middle initial. So now, if you don't put these, if you don't specify this is a character, it will consider this as a string. All right, it will consider this variable as a string, and maybe that's not what you want, right? So to force it, then you say it's a character and it has a as its value. Now, if I try to put more, I should get an error here because it's a character. Yeah, because you can, with characters, you can only have one value, one letter. All right. So the other scenario, you could have, for example, var remaining distance. And then if you make that 30, then the compiler would say, okay, this is an integer. But we know with distance and measurements, you could have decimal points. So in this case, I need to specify either double or float is the other type of variables that can contain decimals in it. All right, the last part, the third case, which is basically when you define data type. In here, you can say data type. And then if you do this here, for example, struct person, and then I will open and close parentheses. In this case, this data type, if you define any attribute in it, so for example, let first name, then I need to specify what is the type of that attribute. All right. Same thing with the var. If you do let var age, and then this case is going to be an integer because it changes. So that's the third case. So if you use data type and then you define attributes with no values in them, then you have to define the data types. I know this was long, but we are done. Again, what you need to do next, you need to go to the labs. You go to lab unit constant and variables. You open the playground, trust and open, and then you follow the instructions here. Here it's a little bit different. So you need to click on next, 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 and then it will take you to there are 10 pages here that you need to follow. All right. Okay, we'll see you in the next lesson.